it may give rise to internal stresses which cannot be perceived by human eyes. Now, what are the characteristics of forces? The main characteristics of forces are its magnitude, how much force we are giving, for example 10 kilonewton. The direction is in which the motion, the force is acting. The nature of the force, whether it is a push or a pull. The point at which the force acts on the body. Sorry for the interruption, guys. I had to take a break. So let's continue again. What is physical independence of forces? If a number of forces are simultaneously acting on a particle, then each of them will produce the same effect which it would have done acting alone. So there is nothing much to explain. If you read the statement once again, you will be able to understand what is physical independence of forces. Principle of transmissibility of forces. If a force acts at a point on a rigid body, it may also be considered to act on any other part along its line of action. So I have drawn a rigid body in the form of an oval, and if a force acts on A, you could easily justify the statement it will act on B, and or you can take the force to be acting on C. That's because B and C are points along the line of its action. So next is resultant force. So what is really a resultant force? Resultant, what do you mean by resultant, guys? So for example, we have four forces, P, Q, R and S, and we denote the resultant force by Z. So the resultant force will be the same force which the four combined will act upon the body. For example, we have P as 10 kilonewton force, Q as 10 kilonewton force, R negative 10 kilonewton force, and S as negative 10 kilonewton force. So the combined resultant force will be 0. Methods for resultant forces. There are two methods, namely analytical and graphical. Under analytical, we have the parallelogram law method and method of resolution. So parallelogram law. According to the parallelogram law, the resultant force is given by the equation root under P square plus Q square plus 2PQ cos theta, where P and Q denotes two forces. R denotes the resultant force. Theta denotes angle between P and Q, and alpha, that's another equation, tan alpha equals to Q sin theta by P plus Q cos theta. So this alpha, which is the angle with which the resultant makes with any of the force. So guys, what is principle of resolution? The algebraic sum of the resolved parts of a number of forces in a given direction is equal to the resolved part of the resultant in the same direction. So according to the diagram that is drawn below, and according to the statement, we find that the summation of the resolved force of P and Q is equivalent to the resultant force R. Now, what is method of resolution for resultant force? So here I have written down the equation R equals to root under summation of vertical forces squared plus summation of horizontal forces squared, and also the equation tan theta equals to summation of vertical forces by summation of horizontal forces. So this part, if you just note down the formulas, you can understand the full thing when we go through the numericals, that is in my next video. So guys, let us discuss the general laws for the resultant forces. The triangle law. If two forces acting simultaneously on a particle be represented in magnitude and direction by two sides of a triangle taken in order, their resultant may be represented in magnitude and direction by the third side of the triangle taken in opposite order. So from the diagram what we see is this is a force of magnitude P and direction is this way, and there is another force Q of some magnitude, direction this way. So the resultant will be this side of the triangle, this magnitude of the triangle, and the direction will be in the opposite way. So for in this case the direction of P and Q are in clockwise direction. So the resultant force will be in anti-clockwise direction. So anti-clockwise in this sense, the arrow depicts the same. Now Polygon law of forces. If a number of forces acting simultaneously on a particle be represented in magnitude and direction by the sides of a polygon taken in order, then the resultant of all these forces may be represented in magnitude and direction by the closing side of the polygon. So nothing much to explain here, just substitute the polygon instead of the triangle that I have explained before, and you will get the concept. Now relation between mass and weight. So you might have heard your mass is always the same. It may be you are on Earth, it may be you are on Moon or any other planet, but weight is not the same. That is because mass is the quantity of matter contained in your body, whereas weight is the force with which the body is attracted towards the center of the planet. So mathematically, weight equals to mg, where m is mass and g is gravitational acceleration. So for Earth, gravitational acceleration is taken as 9.81 meters per second. That's the end of the chapter, guys. That was a theoretical part. The numerical part for the same chapter is explained in my next video.